The Large Hadron Collider smashes protons together at nearly the speed of light, generating petabytes of data from a single experiment. For decades, physicists have sifted through this digital debris by hand, looking for specific signatures predicted by their theories. But what if the most interesting discoveries aren't the ones we are looking for? An algorithm with no preconceived notions about physics was once given raw data from a particle accelerator. It wasn't told to look for a Higgs boson or a top quark. It was just told to find anomalies, patterns that didn't fit. And it did. It found a new type of particle signature, a charm quark jet, that human experts had missed for years, buried in the noise. Your brain is a pattern recognition machine. You see a face in the clouds. You recognize a friend's walk from a block away. You do this by filtering out noise and focusing on relevant features. A machine learning model does something similar, but without the biological limitations. It can perceive patterns across thousands of dimensions, variables that a human mind simply cannot hold at once. Imagine trying to find a single misspelled word in a library containing every book ever written. For a powerful algorithm, this isn't a metaphor. It's just a computational task. It sees the subtle statistical whispers in the data chaos, correlations between particle energies and decay angles that are mathematically real but completely invisible to our intuition. Finding a pattern is one thing. Explaining it is another. This is where a new class of algorithms, sometimes called AI physicists, comes in. One approach is called symbolic regression. You feed the AI data, say the motion of a pendulum. You don't tell it about gravity or energy conservation. You just give it a toolbox of basic mathematical operators: plus, minus, sine, cosine. The algorithm then tries to combine these operators in millions of ways, searching for the simplest equation that perfectly describes the pendulum swing. It essentially rediscovers the laws of physics from scratch. It's not just fitting a curve, it's deriving the fundamental equation that governs the system. In one experiment, an AI was given data from a wildly chaotic system, a double pendulum, famous for its unpredictable motion. Humans have equations for this, but they're complex. The AI was given only raw positional data over time. After processing, it didn't spit out the familiar textbook equations. Instead, it offered a different set of variables, a new way to describe the system's state. When physicists investigated these AI-discovered variables, they were astonished to find they corresponded to real physical quantities, like the system's angular momentum. The AI hadn't just solved the problem, it had independently discovered the deep physical principles governing it, like an alien scientist looking at our universe for the first time. The telescope didn't just let us see farther. It revealed that the Earth was not the center of the universe. The microscope didn't just let us see smaller. It revealed the existence of cells and germs, rewriting biology. These AI systems are a new kind of scientific instrument. Not an instrument for seeing, but an instrument for understanding. It's a complexoscope that allows us to peer into the hidden mathematical structures of reality itself. It can analyze the intricate folding of a protein, the chaotic turbulence of a fluid, or the quantum state of a dozen entangled particles, and extract the underlying principles with a clarity we could never achieve alone. This leads to a strange and profound question. What happens when the laws of physics an AI discovers are no longer simple enough for a human to grasp? We might find an elegant 10-page equation that perfectly describes quantum gravity, but it's derived from a conceptual framework that is entirely alien to the human mind. We could verify the equation's predictions, we would know it works, but we might never have that aha moment of intuitive understanding. Science might split into two branches, the human understandable and the AI discovered, a realm of correct but fundamentally incomprehensible truths about the universe we live in, a physics for a mind greater than our own.
Monotony has grown fast. Nearly 2,700 people have watched in the last few weeks, yet less than 0.03% are subscribed. It would mean a lot if you joined by hitting subscribe. And again, thanks for watching.